Okay, guys. Now can you hear me? Now can you hear me? Hello. Good morning. Good morning. Good morning. Good morning. Acha, V Enthuse fan club keeps 5 alarms. Okay, I'm using a different mic now. I'm using my desktop mic. Guys, can you hear me now? How is it? How is the sound? Yes. Okay. So, Kim, guys, you have to go to school. Okay, interesting. And what about others? Baby Lovey, good morning. Good morning. Hi, Danush. Good morning. And what about others? Oh, Snail wakes up at 5 o'clock. Oh, interesting. With one alarm, that's okay. Very good. V Enthuse fan club keeps alarm at 6:01, 6:05, and then 5 alarms. Okay, so V Enthuse takes 1 hour to get ready. All right. Hi, Naman. Okay, you can hear me pakka here. Very nice. Very good. Very good. Good, guys. So you guys have different techniques for waking up. Very nice. So that's commendable, and I'm so glad, guys, you guys have made it a habit. Trust me, you are going to thank me later at some point in your life because you're going to love the time that you get for yourself throughout the day, plus the health benefits you might not realize. But trust me, if you're sleeping late and waking up late, it will definitely affect your heart, it will definitely affect your brain, and in general, your mental health as well. Welcome aboard. Wow, Cam guys wakes up at 4 o'clock. That's good. In fact, Cam guys, 4 o'clock is a habit of like a lot of really eminent personalities wake up at 4 o'clock. I'm pretty sure you won one day. Wow, guys, he wakes up at 5:20. So guys, if you want to know more about me, you can definitely follow me on my Instagram handle. That's Shreyas_Vedantu. And before we begin our class, do not forget to smash that like button. Go ahead, do that right now in case you have forgotten. Sometimes it happens. And if you're new to this channel, welcome to V Enthuse. This is an English medium channel for all the needs that you have for 11th and 12th examinations, be it boards, be it competitive exam, and anything like that. Welcome aboard. Yes. Oh my God, Baby Luffy has an online test at school at 9 o'clock. Chill, there is a lot of time. We are going to end much before 9. And guys, it's very important. Okay, it's very important. Hi Nisha, good morning. Welcome aboard. Welcome aboard. Yes, very good, Baby Lovey. You have already smashed the like button. Um, See, the board examination is cancelled for 10th. For 12th, the board examination is postponed. That means, do you see an opportunity in this? How many of you see an opportunity just because the board exam has been postponed? How many of you feel good about it? Let me know in the comment section below, or let me know in the chat box right now. Come on, guys. Oh my God. Those of you who sleep late and wake up early, that's very dangerous to health. Even more dangerous. J. Kundal Rao. So never do that. You should sleep minimum for 7 hours. Yes, minimum 7 hours. Alright. So guys, yep, I was asking you something. How many of you see an opportunity just because the board exams have been shifted? So yes, Lionel Messi, you can solve a lot of questions after this session. In fact, Zero to Hero is aimed at that, and a lot of people have transformed their lives because of this. And yes, Lionel Messi will be also able to score goals after this session. Alright, yep. So guys, the thing is, you can now concentrate on the April and the May attempt. And before the April attempt, I'll be ending the Zero to Hero series so that you are well prepared, and also will be conducting mock tests so that you can use this mock test learnings and apply it in your April attempt examinations, and you can give your final attempt in May. So I feel this is an opportunity out there for improving last time without having to worry about boards. So guys, take this plunge. Do not wait for it, because it is definitely going to shape your future. It's going to change your future. And if you want to revise the entire syllabus, do not forget to check out all the details about the crash course, like replace 45 sessions with 11th and 12th standard portions completed. And obviously teachers like me, and I know those teachers who teach really well, who have been persistently working really hard to get amazing results that you see at Vedantu. And also guys, there are test series which are a part of this crash course along with discussions. I mean, that is very important, right? You need actual test pattern papers and most probable questions so that you can actually apply those learnings in your final examination. And also you get doubt solving in the class and outside the class. So any doubt that you have, you can ask to our doubt experts who will solve those doubts instantly. All these features in just merely 10,000, now actually 6,000 rupees after you get a 4,000 rupees discount using the coupon code SHCC. So guys, it's a very nice life-changing opportunity for all of you. Do take the plunge, because definitely your future can change by this small decision that you're going to make. So try that out. The link is there in the description box below. Good morning everyone. Yes, I know Samuel John, in AP exams were not postponed. Will I cover advanced? Yes, Vishal. I have started Killer Fine series right now, which is for JEE Advanced. Okay. Yeah. Hi Nancy. Good morning. Hi Karthik. Good morning. Welcome aboard. Okay. Let's begin. Let's begin. Yes. Let's begin. Now, first of all, let's talk about the wave interference equations. Whenever two waves interfere, they create and they have a path difference. That means they do not arrive simultaneously. Then there is a path difference, and let's say I call that path difference over here. Where is it? Yeah. Let's say the path difference is delta x. That delta x creates a phase difference, and the phase difference, in case you have forgotten, the phase difference formula delta phi is given by 2 pi divided by lambda into delta x. So if my path difference is lambda, if the path difference is 1 lambda, lambda cancels, 2 pi remains, my phase difference is 2 pi radians. So keep this in mind, it will help you a lot. 2 pi radians is 1 wavelength, or 1 wavelength is 2 pi radians. Just keep this concept in mind. Okay. Now, when they interfere, alright, they will produce a resultant wave. They are going to produce a resultant wave. Okay, it was there here. So, that resultant wave's amplitude is given by the vector addition of the amplitudes, by keeping in mind that the phase difference is the angle between the two amplitudes. What do I mean by that? Say for example, this wave's amplitude is 3 meters, and this wave's amplitude example is, let's say, 5 meters, and let's say the phase difference comes out to be 60 degrees. So draw 3, then draw 5, but make sure you draw them at an angle of 60 degrees, and then the vector resultant will be the amplitude of the resultant wave. So when they both merge, the resultant wave's amplitude is given by the vector addition. So basically amplitudes add as if they are vectors. Okay, I hope this is clear. Yeah. Okay, so getting ahead, yeah, I hope everybody has understood till here. Now, what is the meaning of coherent and incoherent sources? Somebody was asking that. I think Aditya. Yes, Aditya Badwar. So the meaning of coherent sources is when the courses are in sync. Courses are in sync. That is called as coherent sources. That means, for example, you might have seen you have two speakers in front of your desktop, let's say. Alright, you have two speakers in front of you. The same wire goes to both the speakers, correct? And this speaker will generate some sound. This speaker will also generate some sound. Now the same wire is fed to both the speakers. Both the speakers will give you the same sound. Correct? The same frequency, same wavelength, same waves, etc. So you will get the same song that you want to hear. But if one speaker is connected to other source and another speaker is connected to some other source, then you will hear two different frequencies randomly, coming out. That is incoherent. I hope this is clear. Biki, this class is for both. And please don't spam Biki, or else you will get blocked by the admin. You ask your question once, I will not answer the questions which are asked more than twice. Okay, so I am not going to answer that. Yes. Now, and by the way guys, this is an English medium channel, so make sure you keep your language in English. Unless and until we are cracking some movie dialogues, we are going to make sure that our language is going to be in English. Okay, there is a separate Hindi channel as well. Okay, now having said that, so whenever sources are coherent, I hope now you have understood, Aditya. Yep. So the whole idea is that, remember, for coherent, the sources are in sync. Coherent means they are in sync. Think of it that way. They are in sync. And incoherent means they are not in sync. They are random. They are random. Okay, they are not in sync. I hope this is clear. Yep, very good. Now this is very important. Lot of times JEE will ask you questions on this. When it is not in sync, what will happen? There will be constructive interference and destructive interference both. Sometimes the waves will interfere constructively, sometimes the waves will interfere destructively. So on an average, what will happen? The total intensity will be I1 plus I2. The total intensity will be I1 plus I2. Yes, I hope this is clear. Yeah. So that's what will happen. Now, when the sources are coherent, those times the intensities will not just add, because remember, you can get this formula. Actually, the formula that you get over here is through this formula. When you use this formula, you get this formula because intensity is directly proportional to the square of the amplitude. Keep this in mind. I hope this is fine. Yeah, I hope this is fine. Yeah. So guys, remember, whenever sources are coherent, use this formula I1 plus I2 plus 2 root I1 I2 cos delta phi. But whenever sources are not coherent, just add the intensities. Do not worry about the phase difference because there is no fixed phase difference between them. Only when they are coherent, there is a fixed phase difference. Is everybody clear about this now? Good morning, Alward. Welcome aboard. Hi, Aman Gupta. Welcome aboard. Yes, baby says everything is fine now. Okay. My God, baby Lucky, instead of counting all the formulas, I would have rather hoped for you to at least learn them. Okay, no problem. Okay, clear? Alright. Let's go ahead. Let's see how many of you can do this question. So, guys, there are two waves, and the path difference between them is asked. Given the phase difference is 13 pi. Phase difference is given. The question is, what is the path difference? Hello, Bala Aditya. Good morning, everyone. Okay, come on. Think. The path difference is asked. The phase difference is given. Phase difference is 13 pi. Which formula are you going to use? Which formula? Hello, cat. Wow, good. You woke up in the morning. Good. I wonder what's the time in Australia around. Okay, so let's have a look at this question. Path difference has to be found. So I think I need this formula. Del phi is equal to 2 pi divided by lambda into delta x. This is the formula that I need, correct? Now del phi, that's given, that's 13 pi. This is equal to 2 pi divided by lambda into delta x, correct? So what next? Obviously pi by, okay, and then I'm going to get delta x from here. That's going to be 13 up, 2 goes down, lambda goes up. So 13 by 2 times of lambda. Now what is 13 divided by 2? Obviously 6.5. And that's the answer. Very good. Looks like Praveen has got it. Yes, Gayatri also got it. Snehal also got it. Beautiful, guys. Looks like you got the hint and you have opened up your account for today morning. Very good. Excelente. Correcto. Let's get moving to the next one. Very good, Srinivas. Alright, Laddu question. Come on, let's do this question then. Come on, is this Laddu or not? We will find out. Two waves having same wavelength lambda are in a vacuum and they are in the same phase initially. So both of them start together. So what this question means is that there are two waves. They start together, but one travels inside a medium whose refractive index is n1. Other one travels in another medium whose refractive index is n2. The length of medium 1 is L1, length of medium 2 is L2. The waves will come out from this, correct? And they are made to merge together. So what will be the phase difference between them? So, path difference between them or phase difference? Yes, phase difference is asked. Phase difference is asked. So when the waves come out, there will be obviously some delta x. From this delta x, you can figure out how much is delta phi. So the question is figure out delta phi, but for that you need delta x. That's your hint. and that's the question, guys. Let's see how many of you are going to do this. Oh my god, it's 11:48 a.m. Okay. Yeah. Well, it's early in the morning out here. Glad you made it. Okay, let's go ahead. Let's see, some of you might have already got the answer. Yes, pretty sure you would have woken up a few hours before. Good, good, good. All right. So let's do this. First of all, there is a simple formula which helps you solve these kind of questions, and the formula is like this. A light wave which travels inside a medium of length L and refractive index n, okay, it gets slowed down because refractive index is there. That means the speed of light will change, it will lower down. It's as good as saying, instead of making that light travel through this particular medium, make that light travel a little bit longer, a longer path, instead of making it travel through a medium slowly. It's like you getting stuck in a traffic jam, alright, or you taking a detour and reaching the end point by taking a long route. Think about it, you taking a detour and taking a long way to reach the same destination. So it's the same thing if you get stuck in traffic with smaller speed, or you take a detour out there. And that detour, so if you go straight through a medium or you take a detour, that detour that you take is n times of L. This is called as the optical path. Keep this in mind. This is called as optical path. Alright? This is a formula which will help you. Now, if you understood this is the detour to reach the same point. Now, refractive index times L. Okay? Keep this in mind. Now, when you have these two waves entering these two mediums of different length and different refractive indices, the question is, what is the path difference? That's the question. So for that I need delta x. Now delta x can be found out by the actual length of the path of one of them minus actual length of the path of the second one. So path length of 1 minus path length of 2. That's all you need to do. So path length of 1 minus path length of 2. But that path length, instead of going through the medium, think of the detour way. Think of the detour way. So, it's like there are two cars. One car went via that way, other car went via that way. So, there is some difference in the path. They both did not reach at the same destination at the same time. So, that will be nothing but N1 L1 minus N2 L2. See if this is understood, guys. No problem, Ankit. No problem, Ankit. Just join in. We are just at the second question and we just covered up a little bit of theory revision at the beginning. Okay. Is this understood? Everybody clear about this? Till now? Everybody understanding this? So the whole idea is, think of two cars starting at the same time, same point. But, one goes like this, other takes another detour, and because of which there is some gap. There is some gap between them. And this is, let's say, N1 L1, and this is, let's say, N2 L2. So this gap is nothing but delta x. Think of it that way. Now, if this much is understood, that's it. From this delta x, you can easily find delta phi. Delta phi will be 2 pi by lambda into delta x, which is N1 L1 minus N2 L2. Because that is delta x. That's the formula. Yep. Understood? So hence, I think this should be the answer. Option C. You can see that. Okay? This should be the answer. Now please understand, in option D it is N2 L1. This is 2, this is 1, this is 1, this is 2. So hence this is wrong. Okay, be careful. So a lot of people who are dyslexic probably might mark this answer, but that is not correct. Yep. Alright. Let's get moving to the next one. And that's option C. Beautiful. Okay. No problem. Happens. Yes. Next question coming up on your screen. Two light sources. Monochromatic means single wavelength. That's all. Of intensity 16 and 9 units. Some units, doesn't matter. 16 and 9. Are interfering. The ratio of intensity of the brightest and the darkest parts of the resultant pattern is. So bright means they are going to interfere constructively. Dark means they are going to interfere destructively. But understand, the destructive part will not have zero intensity. Why? Because 16 and 9, they are unequal intensity, so they will not be able to cancel each other perfectly. The intensities are given. Remember, these are coherent sources. You cannot just add and subtract intensities. You need to worry about the phase difference. Okay, very good. Yes, yes, Gayatri, that's the whole idea. The waves were given to be passing through the medium in the previous one, but optical path is as if you do not have to travel through the medium, yet you get the same effect. So you continue traveling through air so that you feel as if you have traveled through the medium. But since you are traveling through air, you travel a longer path to reach the same point. Is that now clear? Making sense, Gayatri? Okay. Yes, Ankit, the voice has changed because I am no longer using the mic. I think the battery of my mic died, so I had to use my desktop mic, and that desktop mic is a little bit far away, so that's why the voice might sound a little bit different. Okay. So, Sai Srinivas, you can do one thing. You can just go back a little bit in the live class and watch the replay. Okay. So that is allowed, and I mean YouTube permits you to do that. So you can just go back, you can scroll the slider, and you can watch the entire thing again. Alright. Okay. So let's see how to do this question. Now first of all, let's see. Yep. Maximum intensity. Maximum intensity is when both of them are interfering constructively and the phase difference between them is 0. Okay, Praveen already says C, I don't know. And remember, the intensity formula is, in general, let me just write down the general formula. Intensity of the resultant is I1 plus I2 plus 2 root I1 I2 cos del phi. That is the general formula. So over here, I max will be I1, which is 16, plus I2, which is 9, plus 2 root I1, which is again 16, guys. 16 multiplied by 9, cos of 0. Cos 0 is 1. Why this one? Because del phi is 0. Because it is constructive interference. They are going to produce maximum intensity. This is for bright part. This is for the bright part. Similarly, for the dark part, what will be the minimum intensity? 16 plus 9 plus 2 root 16 into 9. Instead of 1, it will be minus 1. Yes. Why minus 1? Because del phi will be 180 degrees. It's a destructive interference. Destructive interference. I hope this is clear. I hope this is clear. Now, next thing that you need to do is just take the division of both of them. So I max divided by I minimum. Now let's think about it. 16 plus 9 plus 2 root 16 into 9. Guys, I think this is the expansion of something. Or, okay, even if you don't want to expand, let's just do it normally. 16 plus 9, how much is it? It's nothing but 25. Plus 2 multiplied by 16's root 4, 9's root 3, 4 into 3, 12. Correct? I hope this is fine. 16's root is 4, 9's root is 3, so 4 3's are 12. And over here, we will have 25 minus, because that minus sign is there, 2 into 12. As simple as that. So guys, 12 twos are, how much is it? Come on, how much is 12 twos are? 24. 24 plus 25, how much is it? 49. And this is 25 minus 24, which is 1. And that's the option D. Yep. It's not D, it's D. It happens. Some of you got it before, some of you did not get it before. But now, I hope you guys understood it. So whenever there is a question on bright thing, that means it's constructive, that means phase difference is 0. And you will substitute 0 in this formula. Whenever there is a dark region, dark fringe, etc., it's destructive interference and phase difference is 180. So substitute that over here, and that's how you will solve it. Okay, let's get moving to the next one. Coming up on your screen. Get ready. Okay. Now, yep, there we go. Yes, that's the answer. Very good. Now let's talk about YDSC interference. Now, a lot of questions are going to come. a lot of questions are going to come from Young's double slit experiment. And this famous experiment is nothing but you have two sources of light which are in sync with each other and they produce a same pattern which interferes on the screen. So two sources producing same pattern or same waves or same frequency with same wavelength, and there is a screen at some distance. The separation between the two sources is small d. Then on the screen you get alternative bright dark fringes, and that fringe pattern helps us identify what's the wavelength, how much is the distance between the sources, or anything else. Also there are formulas for fringe width and a lot of stuff. So first of all, if you take any point on the screen, remember the formula for phase difference. You take any point on the screen, the rays traveling from source 1 and the rays traveling from source 2, they travel unequal paths before they meet at point P, because of which there is some extra distance the rays from other source have to travel. Because the path lengths are different, the rays of light have to travel an extra distance, and that path difference, remember, is always d sine theta. What is theta, you might say? Theta is the angular position, that means angle wise, what is my location, what is my position on the screen? Is it 30 degrees up, 10 degrees up, minus 15 degrees down? So that is the angular position of that point on the screen with respect to the two sources. I hope this is clear. Okay. And from this, you can write this to be like, what do you say? If it is lambda or basically n times of lambda, then it is constructive interference. And if it is odd times of lambda by 2, then it is destructive interference. So for all those thetas where d sine theta is n times of lambda, so for all those points whose theta gives you, d sine theta is n times of some integer times of lambda, all those points will have bright fringes or there will be constructive interference. All those thetas which will give you this relationship, d sine theta is some odd number into lambda by 2, all those points will have destructive interference. Keep this in mind. And last thing but not the least, sine theta is approximately tan theta if this theta is small, and this helps us in many approximations, like tan theta will be nothing but opposite side by adjacent side. So tan theta will be nothing but y divided by d. So you can substitute this over here if you would like to. So sin theta is tan theta is y by d is a very important approximation for small angles. Keep this in mind. So instead of doing all this, I have helped you understand this through my explanation out there. And last thing, yes, do not forget the fringe width formula, lambda d by d. This is very important formula, guys. Lambda d by d. Optical path, I did it before. This is when you place some kind of a slab in between. Then the longer, basically the detour that you take is refractive index times the length of the slab. So that's standard. All these things are okay. I have already told you this formula. So just remember this one, and everything else will be fine. Okay. So lambda times d by d is the fringe width. So from one bright to the next bright is called as the fringe width. This is the fringe width. Keep this in mind. So this is bright, there is a dark region over here. This is how it looks. Okay, let's move ahead. And here is your first question. The maximum number of possible interference maximas for a slit separation equal to 1.8 lambda, where lambda is the wavelength of light in a Young's double slit experiment, is how much? Let's see how many of you can do this. Hi Divya, you missed a couple of questions, but maybe in the replay you can watch it. For now, just continue with the live class. Hello man. Okay. Okay, so we have the two slits over here, and the separation between them is D. Here is the screen. Okay, here is the screen. The question is, how many number of maximas are you going to get? How many number of maximas are you going to get? The value of D is given to be 1.8 lambda. Let's see how you can answer this really quick. Is there any relationship between intensity and the width of the slit? Yes, Praveen. In fact, remember the intensity, alright, the intensity is directly proportional to the width of the slit. Width of the slit. So if you have a larger slit, more light will pass and each slit will behave like a brighter source. Usually in Young's double slit experiment, both the slits are of the same width. So that's why the intensities are equal and that's why they will have a perfect constructive and destructive interference. But if the widths are unequal, then you will not get perfect cancelling of those waves because the intensities are not equal. Okay, I hope that answers your question. Hello Amrita Raj, welcome aboard. Good morning. Yes, good morning. Let's begin with this solution now. First of all, now I'll tell you a general way of solving these problems. The general way is like this. Now forget all this. Just forget this for a minute. Just imagine, okay, this is our screen. These are our two sources, S1 and S2, and the distance between them, okay, the distance between them is D. Okay, just imagine this. And now I tell you guys, okay, and now I tell you, if I am directly opposite to the two sources at the origin, my path difference will be 0. Do you guys agree with that? Do you guys agree with that? If you are directly in front of it, both the rays will travel the same amount, so there is no path difference over there. Now, you move somewhere else. Let's say you go somewhere here. Okay, you go somewhere here. Don't you see that your delta x will increase, guys? Don't you see your delta x will increase? Think about it. Because one ray is traveling little bit more than the other ray. You can see that. Now move more on the top. As you move on the top, you will see the path difference or the difference in their lengths of traveling for each of the rays will change, and in fact it will keep increasing. In fact, when you go here really far away, think about it, almost when you are reaching towards infinity or very far end of the screen, then the rays almost have to travel in such a way that the difference is exactly or almost equal to D. Think about it. When the rays almost become like this, almost 90 degrees, the rays meet at infinity, one ray has to travel D distance more than the other ray. Almost. So when you are at infinity, the rays will look like this. Okay, and this ray will travel D distance more than the other ray. I hope this much part is clear. If this much part is clear, now try and understand this logic also. If this is my screen, if these are my two sources, okay, and the distance between them, D, is equal to 1.8 lambda. Okay, 1.8 lambda. So think about it. The point which is directly opposite, the path difference is 0 lambda because both the rays meet simultaneously. Somewhere, I don't know where, but somewhere the path difference will be 1 lambda. Correct? Somewhere the path difference will be 1 lambda. And will there be a point where the path difference will be 2 lambda? Think about it. Will there be a point where the path difference is 2 lambda? Think about it. I don't think so because the distance between them only is 1.8. The max possible, so understand, delta x max itself is 1.8 lambda. So that's the maximum difference that you can get. So 2 lambda, well, that's not possible. I hope this is clear. So same way, you will also get another point somewhere over here which will have again 1 lambda as the path difference. So all these three are nothing but bright regions or maximas. So how many maximas are you going to get? You are going to get 3 maximas. Yes, Devi. Very good. Understood, Nancy. Excellent. Have others also understood this? If you guys have understood this, let's move ahead. Let's move ahead. Okay, clear everyone? Can we move ahead, guys? Yep. Understood everyone? Okay. So 0 lambda at the center, then you have 1 lambda, and that's it. Okay. Let's get moving. That's option B. Okay. Next question coming up on your screen. Let's see how many of you can do this. Yep. Come on, everyone. Do this. So statement 1 says in Young's double slit experiment, the number of fringes observed in the field of view is small with longer wavelength of light and is large with shorter wavelength of light. That's statement 1. Statement 2 is in double slit experiment, the fringe width depends directly on the wavelength of light. Come on, think about it. Think everyone. Yep. Waiting for all of you to give the answer. It's not that difficult, trust me. Yep. Let's do this. If you guys are done. Okay. I'll tell you what. Just use a simple formula. And the simple formula is beta is equal to lambda d by t. Just use this. In YDSE, the number of fringes observed in the field of view is small with longer wavelength and is large with shorter wavelength. See, very simple, guys. If lambda increases, fringe width increases. Fringes will become bigger and bigger, correct? Fringes will become bigger and bigger if you use larger wavelength. If you have bigger fringe width, the number of fringes that will fit inside a particular region will become less. So large fringe width will mean less number of fringes in a particular region because the width has increased. It's like how many fat people can sit in a room. So if you have thin people, you can accommodate more people, but if you have fat people, then obviously there will be fewer number of people inside that room. So as simple as that. So guys, that statement 1 is absolutely correct. And in the YDSE experiment, the fringe width depends directly on the wavelength. Exactly. That is also correct from this formula. So in fact, it is the correct explanation of statement 1. So statement 2 explains statement 1 by saying if you increase the wavelength, the fringe width will increase, and because the width has become more, so you will be able to accommodate lesser number of fringes in that particular region. So that's option A, guys. Excellent. Very good. Yeah. Let's get moving to the next question. Beautiful question, guys. Beautiful question. I'll tell you what. In YDSE experiment with light of wavelength lambda, a fringe pattern is seen with width beta. Okay. Now, when two thin transparent glass plates of thickness T1 and T2 are placed in the path of the beams, then the fringe pattern will shift by. Okay. Now, often people find these kind of questions difficult. So, first of all, let's try to understand what exactly a glass slab does. Let's try to understand this. See, if this is my screen, this is my source 1, and this is my source number 2, and this is my slab, glass slab over here. Usually, what would happen? Usually, this is without the slab. Just imagine the slab is not there. Then the rays will reach simultaneously at this point O. The rays will meet simultaneously over here, and you will get a maxima over here, or basically bright region over here. Usually, exactly at the center. Because both the rays will travel equal distances. But because of that slab, what happens? One of the ray gets slowed down than the other. So both might leave simultaneously, but ray number 1 will get slowed down, and by the time they reach over here, there is already some path difference. So it has slowed down. Bechara, it has slowed down. So what you do? You make him travel lesser distance. It's like he has become the weaker sibling. He has become really weak because he is traveling slowly. So you ask him, okay, you don't travel as much as the other one, you travel less. So ray number 1 travels less and ray number 2 travels more. That will compensate for that, and that's why you will see this point will now shift over here. So this is basically your shift. Is that point understood, guys? Is this point understood? Yes, the point will shift because the ray which will travel through one has slowed down. So you make him travel shorter distance. The other ray you make him travel longer distance to compensate for the time. So basically both of them will end up reaching simultaneously. Now if this much is clear, let me go ahead. Let me go ahead and tell you what to do next. So first of all, the whole idea is, just because of one slab, just figure out how much is the shift. Just because of one slab, how much is the shift? If you know that formula, well and good. If you do not know, don't worry, I'll tell you how to get that. So, these are the two rays coming from source 1 and source 2, and there we go. We have a slab over here like this. We have a slab over here, and usually what used to happen, this used to be my origin, but now this is my shift. Let's say that shift is y. Example, that shift is nothing but y. Okay. Now the whole idea over here is that at this point, because both of them reach simultaneously, what is the path difference? Effectively 0, right? The effective path difference is 0. Do you guys understand this? The effective path difference is 0 because both of them reach simultaneously. They are simultaneous. Understand it? So whatever effect the slab had in slowing down, exactly that much effect the two rays, because of their actual path difference, had. The two rays, because one is traveling more than the other, that extra distance you are making him travel is exactly because, or rather it's compensated by the path difference created by the slab alone. So I hope if you visualize this clearly, the path difference by the slab is equal to the path difference created by the actual path lengths. And what is the path difference created by the slab? There's a standard formula. I just gave it to you guys. What was that formula? Alright, it is thickness into mu minus 1. Remember this, thickness into mu minus 1 is the formula. So that is on this side, and path difference, just because of their actual paths, I had told that to you, that is d sine theta. And remember, sine theta is tan theta, and remember tan theta is opposite by adjacent, so it is y divided by d. That is y divided by d. Yeah. So basically what you will get from this particular logic is that the value of y is t into mu minus 1. Alright, t into mu minus 1. That small d comes below and the capital D goes on the top. That's what you are going to get. So this is a standard formula. So because of a slab, how much path difference is created? Thickness into mu minus 1. That's standard. So the rest things are basically, the difference created by the slab is the same difference to compensate. This equal to, why have I written this equal to? This is just to compensate. So that they both reach simultaneously. That's it. So that they both reach simultaneously. Now, once you know this, everything else is simple. I'll just erase all of this. I don't need it. This was just because of one slab. Now, because both the slabs are there, one slab will shift it this way, the other slab will shift it the other way. So the net shift will be y1 minus y2. Understand? One slab will try to shift it up, other slab will try to shift it down. So it will be thickness. Thicknesses are different, I guess. So T1 into mu minus 1 into d upon small d minus T2 into mu minus 1 into d divided by small d. So take it in common. So you'll have T1 minus T2, alright, mu minus 1 into D divided by small d. So that's it. Okay, one last thing before we go ahead. Just multiply this with lambda and divide it with lambda. Why did I do that? Because lambda d by d is fringe width. Lambda d by d is fringe width. Yes. So you have beta, you have mu minus 1, you have T1 minus T2, and you also have that remaining lambda over here. So that means option C will be correct. Option C will be correct. I hope this is clear. Shall we go ahead? Beautiful question. It's a very lengthy question. Most likely it can be asked as advanced question as well. Okay, and even if it comes in mains, this will decide whether you get 100 percentile or not. Okay, so let's move ahead then. Sure, let's get going. Option C is correct. Yep. Now, moving ahead. Okay, so this is how our wave platform looks like. So, all the details, etc., are mentioned in the slides as well. This is how you can ask doubts. You can check it out, guys, later on when I send you the PDF. Let's come to the last part, which is electromagnetic waves. Now, electromagnetic waves, standard formulas you should know. Like electric field is E sine kx plus minus omega t is the equation for the electric field, and B naught sine kx plus minus omega t is the equation for the magnetic field. So electric field and magnetic field are always perpendicular to each other, and they always travel as electromagnetic waves. Light travels as electromagnetic waves, where electric field, magnetic field are perpendicular, given by these equations. Then speed of light formula is E by B. Electric field by magnetic field also it's 1 by root mu E. Standard formulas which you should know. And pressure formula. So whenever light of intensity I falls on some surface which absorbs it, the pressure it exerts on that surface is I by C. But if that surface is reflective, alright, then it is 2I by C. Keep that in mind. So all these things are standard formulas. And last thing, intensity formula. So that intensity of light is half electric field magnetic field by mu naught. So you can write it in different forms, but these are the standard equations. So let's start doing some problems. All those things are there in your slides. So there is a wave of frequency 3 megahertz. It passes from vacuum to a dielectric medium with permittivity 4. Then what do you think will happen? Yes, electromagnetic waves. So wave optics, Avantika, is already done. I just did it. Now that was wave optics. Now we are coming to light waves. So today I wanted to do only light waves. Everything related to waves and light is what we are doing in this 0 to hero series. Okay. Yes. Good morning, breeze, raining clouds, awesome class. Nice. We have fire, we have rain. Okay. So first of all, the relative permittivity is 4. Okay. So there is a permittivity of 4. So what will happen is, remember speed of light is 1 upon root of mu naught epsilon naught, but this is for vacuum. So this is in vacuum. So in some other medium, okay, what will be the formula? It will be root of mu naught epsilon naught. I think the word which is missing over here with a relative. This should be relative, guys. This should be relative. This should have relative permittivity, not just permittivity. So the permittivity constant will get multiplied by 4. I hope you can see that the permittivity constant will get multiplied by 4, because actually the word should have in relative permittivity. So this will become, so root of 4 is 2. So it will become 1 by 2, and the rest of the things is nothing but speed of light in vacuum. So this is speed of light in that medium, and it is half of the speed of light in air or in vacuum, we can say. So that means, think about it, C naught by Cm, alright, C naught by Cm is 2, which is also going to be the refractive index. So that is the refractive index. Now, if this much is clear, if you know the refractive index is going to be 2, and you know speed of light in vacuum and in medium, the ratio is 2. Remember, speed of light is frequency into wavelength. Now frequency will never change. So it will be frequency into wavelength in vacuum upon frequency into wavelength in that medium. Anyways, frequency will get cancelled. The ratio will be 2. So guys, frequency will not change no matter what. So frequency remains unchanged. Frequency remains unchanged. Frequency remains unchanged. But wavelength will be, look at that, the wavelength has become half times. Do you see that? Yes, do you see that the wavelength has actually become half times? So wavelength is half, frequency remains unchanged. So that should be the answer. Because you can see from here that lambda m is nothing but lambda naught divided by 2 from over here. So that's the way to solve this. Yeah. Let's get moving to the next question. Okay. So that's option C. Moving to the next one. Average energy density of an electromagnetic wave of this much electric field is given by. How much is the average? Okay. Cross product formulas, Aditya Verma. The thing is, see, you should just know this particular thing. I'll come to that in the next slide actually. There's a question on that. I'll be talking about that formula. I'll just revise those formulas, Aditya Verma, in the next slide itself. Okay. Come on, let's do that. The average energy density of electromagnetic wave for this wave equation is given by. Come on. How do you do this? Come on, let's see. The average energy density. Well, I'll tell you what. The standard formula for energy density is half epsilon E square, standard formula. So half is there. What is the value of epsilon? Approximately. The value of epsilon is approximately 9 into 10 to the power minus 12. Okay, approximately. Actually, it is 8.85 or something like that. Okay. And into E. E is over here, which is almost 50 square. Now you do the math and see how much approximately does it come out to be. Approximately. Just check this out. So 9 into 25 divided by 2, and this is 10 to the power minus 10, and 25 into 9, guys, that's 225 divided by 2, that's 112. Alright, 112.5, just check this out. Yep. And into 10 to the power minus 10, this you can write it as 1.125 into 10 to the power. Okay, in 10 to the power, how much? You take those decimals out there, what will it become? It will become 10 to the power minus 8. So hence, it's approximately 10 to the power minus 8. That's option A. Very good, baby lovely, very good. Yes, excellent. That's option A. Very good. Let's see the next question coming up on your screen, and here it is. The field is given by E naught cos omega t minus kx. Then the magnetic field at the same moment is given by. The field is given by this particular equation. Then the magnetic field at the same time t is equal to 0 is given by. Come on, think about it. Yes. Come on. Snehal, sir, isn't 50 not? No, it was 5 square, 50 square. Okay, half epsilon naught e square. Half epsilon naught e square. So 50 square was there. So 5 square is 25, and that's what we get. Okay. Yes. Okay. Cool. Let's get going to the next one. Come on, everyone. Let's see how many. Okay. Come on. Yep. A. I don't know. I'll tell you what. See, guys, what you need to do is at t is equal to 0, right? So electric field at t is equal to 0 will be E naught cos minus kx j hat. Now cos of minus theta is cos theta only. It's cos theta. So it will be cos at kx j hat. So that's electric field at t is equal to 0. Now remember one thing. Somebody was asking that. I think Aditya Verma was asking this. Now remember, electric field cross magnetic field is parallel to the speed of light. E cross B is C. Remember that. Now what is the direction of electric field? Well, that's j cap. The direction of magnetic field, I do not know. Will be parallel to speed of light. Where is the light traveling? Oh, come on. This is an equation in the x line. So it is traveling in the x axis, that is I cap. You can see that. it's traveling in the I cap direction. So J cross what unit vector will give you I cap? J cross I? No. J cross J? No. J cross K? Yes. So J cross K is going to give you I cap, unit vector parallel to I cap. So that means the magnetic field at t is equal to 0 will be something K cap. Remember that. It will be something K cap. So I think only two options have. B option goes away, D option goes away. Now how do you get the value over here? Well, that has to be some V0 cos kx. Obviously, it will be very similar. But what will the value of this V0 be? That can be found using this simple relationship. Remember, field, electric field by magnetic field is 1 by root mu naught E naught. So that's it. So B naught will be, think about it, it will be E naught into root of permeability into permittivity. So just substitute that and I think you're going to get the answer. So the answer is C. Sure. Yep, it is C actually. Because this one is there downstairs. So this is not correct. It should be C. Yep, that's the answer. So all the formulas used over here, wave equation, E by B is speed of light, and the cross product formula as well. So beautiful question out there. Okay, let's get to the last part. And the last part is basically polarization of light. Remember, when light travels, there is electric field in one plane and there is magnetic field in one plane. So that plane which contains the electric field is contained as the plane of that light, of that plane of polarization of that light. So a light which travels, it has two planes, electric field and magnetic field. The plane which contains electric field is called as the plane of polarization of the light. Now usual light which comes around us is not polarized. That means the light which comes, sometimes the plane is like this, sometimes the electric field is like this, sometimes the electric field is like this, sometimes it is like this, sometimes it is like that. It's all at random. It is unpolarized. So those lights are unpolarized lights. So what happens is that when this unpolarized light passes through, alright, it passes through something called as a polarizer, it gets polarized. So there are different planes in which the electric field components are there. Only one particular component passes on the other side, so the light gets polarized. So now you have a polarized light where the plane of the electric field is only in one particular direction. Now again, if you pass this light through another polarizer, then different things can happen. So for example, if the plane of oscillation of the electric field is exactly aligned with the plane of that polarizer, the plane of the polarizer and the plane of light is exactly matching, then everything will pass in. But if it is at 90 degree, then nothing will be able to pass through the polarizer. Okay, so light will be completely blocked. But if it is at some angle, so that light which is having electric field in one plane and the polarizer is making some angle, then only a part of it will go. So the intensity of the light which comes out on the other side is given by incident intensity into cos square theta, where theta is the angle between the polarizer and the plane of light. Okay, so that's what it is. Yes, and creations, yeah, I do. Okay, last one out here, Brewster's law. Whenever unpolarized light falls on a medium, part of it gets reflected, part of it gets refracted inside the medium. If that angle of incidence is such that refractive index is tan theta, refractive index is tan of angle of incidence, then the light which gets reflected is polarized. Yes, this is the Brewster's law. The light which gets reflected is polarized. Not only that, the reflected light and the refracted rays are going to be perpendicular to each other. That's what Brewster's law says. So let's do this question. When an unpolarized light of intensity is incident on a polarizing sheet, the intensity of light which does not get transmitted is, come on everyone, think. Yep, come on everyone, think. when unpolarized light of intensity I naught is incident on a polarizer sheet, the intensity of light which does not get transmitted, is, what is the answer? Hi Shavi, good morning. Yep. Let's see how many of you can do this. Unpolarized light, when it passes, only half of the light will go in, half of the light will not go in. Yes, it is I naught by 2. Correcto. Unpolarized light. So when you have, how do you show unpolarized light? Something like this. This is the symbol of unpolarized light that says the plane of oscillation of the electric field is in every possible way, and this is the polarizer. Okay, the polarizer only allows light which has planes only in this direction. The light which comes out is only like this. This is unpolarized. This is just simple polarized. Only half of it will be able to go in. Yes, that's the answer. Half of it will not be transmitted inside. Excellent. Let's see how many of you can do this. Two Polaroids, that means two polarizers, had their directions parallel so that the intensity of transmitted light is maximum. Okay, let's think about it. The angle through which one of the Polaroid must be turned so that there is a drop to 1/2 is. Let's solve this step by step. So first, what is happening? There is unpolarized light again. So this is unpolarized. It passes through a polarizer. Okay, it passes through a polarizer. So once it passes through a polarizer, this unpolarized light which had intensity I naught, it will become polarized of intensity I naught. Okay, so you are going to get intensity I naught, but only half of the light will make it in. But remember, there are two Polaroids such that they are parallel to each other and maximum light will transmit. That means the second polarizer also has their plane parallel to the original polarizer. So whatever light enters in, gets polarized, will continue doing so unaffected. So it will remain polarized. There is no angle, there is no shift. So you will still have I naught intensity over here. Okay, sorry, I naught by 2, my bad. This was I naught by 2. So it gets polarized half the intensity and then it continues over here without getting affected because they are parallel, there is no angle, there is no shift, and the planes match. So same light will go inside. Yeah. Now, in the second situation, let's see what is exactly happening. Again, you have unpolarized light. Okay, you have unpolarized light. The intensity is I naught. First polarizer doesn't matter how it is, so it will just become polarized of intensity I naught by 2. Okay, but in the second one, because it is turned by an angle theta, the intensity becomes half of the previous one. What was the previous intensity? I naught by 2. So what is the new intensity? Half of that. So that is nothing but I naught by 4. That's the intensity of light which comes out of this polarizer. So now think about it. What is the angle? Well, that I can figure it out very easily. I can figure it out very simple, very easy. Think about it. I naught by 4 will be this intensity, I naught by 2 cos square theta. The final intensity will be initial intensity cos square theta. This is what Malu's law says. Okay, now what will you get? You are going to get half is equal to cos square theta. That means cos theta is 1 by root 2. That means theta is 45 degrees. But you can also take 135 degrees. See, just because it is 1 by root 2, it doesn't matter. You can also take 135 degrees. So, because 45 degrees was not there in the option, I'll end up marking 135 degrees. I hope this is clear. Yeah, this was the last question for today. Yep. The answer is 135 degrees. I hope you guys understood this. Beautiful question. Now, let me show you how to exactly join the crash course, guys. So if you check out any video, alright, so if you check out any video of ours, let's say for example, okay, I don't know, let's say yesterday's lecture, okay, electrostatics, Okay, oops, let me stop it. Yep. And if you see the description box over here, okay, you will see a link for joining the crash course. Just click on that link and you will see two options. A crash course which starts from 5th April and a crash course which starts on 3rd of May. And it's very important to know that since the board exams have been postponed, this is the best time to crack JEE exam, and this is the last chance after this. So this is like the final call before all the options are going to run out. And this crash course which ends on 22nd April is aimed at all the students who want to complete everything before the April attempt. And those of you who are planning to give it in May, you can start your crash course on 3rd of May. But I feel earlier you start, the better it is. You can choose whichever you want. You can boost your rank by covering the entire syllabus in all these sessions by obviously the best master teachers. So you can get all your doubts resolved by just uploading the picture through the doubt app. And there will be strategy sessions and tips and tricks sessions to help you boost your rank by whatever you are supposed to get. So if you are supposed to get 96 percentile, you will get 97 percentile, 98 percentile. So boost your rank using these strategy sessions. Plus 20 JEE test series which you can give whenever you want, even after the course end date. That's very important. And you will also have doubt discussions and discussion sessions after every test. So all of this, every detail has been mentioned over here, okay, and all the ranks, etc., whatever were there. So when you click on buy now, understand there will be an option to enter the coupon code. Make sure you select or you type out SHCC. The moment you apply SHCC, you will save 4,000 rupees, and you can even pay it through EMI, or even you can pay through credit card or Paytm. So a lot of options are there, or Amazon Pay. So it's a very good deal considering the fact that your ranks will be boosted in this final attempt of JEE Mains, and this is probably going to change your life. Alright, so guys, I hope you have enjoyed today's session, and I hope I'll see you again tonight, alright, in the last session of electrostatics, which is field and potential lines. Very interesting session which is going to be coming up at 9 o'clock tonight. Bye bye guys. Thank you for tuning in. Thank you everyone for tuning in the morning. Yes, Kat, we do have schools in India, but unfortunately, or I don't know what, school coaching is not at all really good, and these competitive examinations can be only cracked only when you attend coaching. So the school education that we get in India is in a very, very bad state. That's the reason why we have to come out here, so that we can help all these students excel in their studies. Else we had no reason to be here. Yes, the timetable for today's Snehal will be uploaded in a very short while, but the whole plan, you can check out the upcoming streams as well. So if you go to our channel, alright, if you go to our channel over here, you will see upcoming streams. So you can see it over here, alright, upcoming live streams. So this is mostly the timetable. Okay, cool. So that's it for today, guys. Bye bye. Please do not forget to like the video, and do not forget to share and subscribe to our channel in case you haven't. Bye bye. Take care. See you.